Let's say there is a tree. This is your root. Okay. Such kind of a tree is also called as a perfect tree. Of course, it has a different names in different places. But why I'm calling it a perfect tree is because you can see that it is a perfect triangle. So there is a root and it has two child. Again, there is a root. Sorry, there is a node, it has two child. Again, there is a node that has two child. So the property of this tree is that all these levels that you can see are completely full. Level 1 is full, level 2 is full, level 3, level 4, all these levels are full. And in the last level, all the leaves are present. Okay. Okay, so can you count the number of levels? How many levels are there in this tree? Okay, so there are 4 levels. So this is your level 1, level 2, level 3, level 4. Now, if let's say you have a perfect tree where the number of levels is, let's say, h, then how many nodes will be there in that tree? Very simple question. What is the total number of nodes in a perfect tree? Let me write perfect tree where number of levels is h. Okay, so you guys are saying 2 raised to power n minus 1. Do you see there is no n? From where you are bringing n? I said number of levels is h, and then I'm asking number of nodes. So your answer should be in terms of h, right? Okay, many of you are saying 2 raised to power h minus 1, and some of you are saying different. So let's take a look at that. See, here there will be only one root, right? And because the tree is perfect, at next level there will be 2 children of it. At the next level, 4. At the next level, 8. So in general, I can say if there are h levels, here I'll have 1. Here, this 1 is also 2 power 0. And then 2 power 1 nodes here. And then 2 power 2 nodes here. So on and on, 2 power h minus 1 nodes at the last level. And now if you take a look at this thing, 2 power 0 plus 2 power 1 plus 2 power 2 till 2 power h minus 1, then this is a very special kind of series. This is a, which kind of series? GP, geometric progression. Now, do you guys know the sum of GP? You can take a look at that. It's a very basic maths. It is A, where A is the first term, into R, where R is the common ratio raised to n minus 1 upon R minus 1. R is the common ratio. The common ratio here is 2 because every next term is 2 times the previous term. The first term here is 1 and the R is 2. The number of terms from 0 to h minus 1 will be h minus 1 upon 2 minus 1. So this 1 and 1 is gone. So it will be 2 raised to power h minus 1. So the total number of nodes is 2 raised to power h minus 1, which is also order of 2 raised to power h. So I can say as the height of the tree increases, this h is height. As the height of the tree increases, and if it's a perfect tree, then the number of nodes will exponentially increase, because in every below level, the number of nodes will become twice of the previous one. So it's just like a binary fission reaction that is happening. It can be modeled as a tree. Or does it make sense to everyone that how is it 2 raised to power h minus 1? Similarly, so if let's say I call this thing n, because n is the number of nodes. Now, if somebody asks you reverse question that, hey, if there are n nodes, then what will be the height? If the tree is perfect. If there are n nodes, then what will be the height if the tree is perfect? Can you think about that? It will be log of n base 2. Why log of n base 2? Because if you take log of this thing, see, this thing is almost 2 power h. So if you are taking log of 2 power h base 2, you will get h, which is the height. So if there are n nodes and if the tree is perfect, then the height of that will be log of n base 2. Okay, now let's come to some worst cases. I told you that in a binary tree, a node can have at max 2 child. So the worst case could be that every node has 1 child only, just like a linked list. So in that case, what will happen? You have a root, it has a child, 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 and so on and on and on. Such kind of a tree is also called as a skewed tree. Skewed in one direction. So it goes like right, 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 or it could go like left, 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 left. Okay. In this case, log of n plus 1. Again, like that does not make sense what you are asking, because when you are doing asymptotic analysis, how is log of n different from log of n plus 1? There is no difference. They are almost the same. Okay. So when you learn about time and space complexity broadly, you will learn that. But answer me this thing. If there are n nodes and the tree is skewed, then what will be the height of such a tree? It'll be n, because you can say that each level has only one child. Cool.